Okay, so let's go ahead and go over the warm-up. So let's see, we've got expand, so that's log base 6, 3 log base 6 of A minus 12 log base 6 of B. That's it. And then the second one should be 10 log base 8 of X plus 5 log base 8 of Y. And then condensing, let's see, I'm going to slide this up. Log base 3, and it's a plus sign, so I've got u to the 6 times v squared. Okay. And then the number 4 should be log base 3. We got a plus and a minus. So a to the 5th, b to the 30th, all over c to the 10th. Questions? Everything that I saw in there in the box looked good. So good job, you guys. Okay. So now we're going to move to solving logarithms, okay? And there's 2 different lessons. We split it into 2 different parts, into the one-to-one property and in where we're going to use the properties of logarithms to solve. So, yeah, we'll talk about that tomorrow. But this one's the easier of the 2, of course. And it says, using the one-to-one property, what it means is if I have 2 exponents, so I have a to the x equals a to the y, the bases are the same. Notice that they're both a's. Then in order for them to be equal, the exponents have to be equal is basically what it's saying. So as long as the bases are the same, in order for them to be equal, x has to equal y. That's what it's saying. So if the bases aren't the same, I got to try and change the bases so they are the same. Okay? Or there's another way we can do it also. When we get to a problem, we'll go there. Then again, same thing with the logarithms. As long as my bases, as long as my bases here are the same, right? As long as the bases are the same, in order for them to be equal, these 2 parts have to be equal to each other. So if it's log base a of something equals log base a of something else, those 2 somethings have to equal each other in order for my 2 logs to equal each other. That's all it's saying. Okay? So let's go ahead and look at these. So number 1 has bases the same. They have a 5, base 5, right? 5 to the 7th power equals 5 to the 3 minus x. And please make sure you're asking questions if this is kind of confusing, because even in my head, sometimes my words don't sound right today. So I'm having a confusing word day, just so you guys know. So make sure you're asking questions. At least to myself, maybe it's making sense to you guys. Okay, so bases are the same. That means what I'm going to do, all I'm going to do is I'm going to take my exponents, which are these 2, and set them equal to each other and solve. So 7 is going to be 3 equals 3 minus x. In order to solve for x, I'm just going to solve that equation. That's it. Subtract 3, 4 equals negative x. Divide by negative 1. X equals negative 4. And that's my answer. Done. Because my bases were the same. So on number 2, I can make my bases the same because I can change 81. I'm just going to do it this way. I think I'm going to do it 2 different ways and show you both ways, and then you can decide which way you like better. How's that? Okay, so we're going to do this 2 different ways. And so the first way, I'm going to change the base of 81 because 81 is 3 times 3, and 3 times 3 is 9, and 3 times 3 is 9. 9 times 9 is 81. So 3 to the 4th power is 81. So I could rewrite this as 3 to the 2x plus 1 equals 3 to the 4th power. Now my bases are the same. I have a 3 and a 3. And so I can set my exponents equal just like what I did on the first one. So that would be 2x plus 1 equals 4. Subtract 1. 2x equals 3. Divide by 2. 2. And x equals 3 halves, right? If I have any room anywhere. X equals 3 halves, okay? There's another way to do this. If I have an exponent only on one side, and it's only if I have an exponent only on one side, so like this one, I can change this from an exponent to a logarithm. And where did the 4 come from? Yeah, Sophie. So 81, if you look at, can you see me in the camera up there? So this is how I think of 81. I know that 81 is 3 times 3 is 9, so there's 2 3s, right? And 3 times 3 is 9, and 9 times 9 is 81. So that was 4 3s. So 3 times 3 times 3 times 3 is 81. Does that help? Okay. Yeah. So I'm sorry, you probably weren't the only one that had that question, but that was a great question, by the way. Okay, so another way I think about this is since the exponent's only on one side, I know we learned our very first lesson how to switch from a logarithm to an exponent and from an exponent to a logarithm. So I'm going to rewrite this as a logarithm and see if I can solve it from there. So I have log base 3 of 81, remember? Log base 3 of this equals 2x plus 1. So do I know log base 3 of 81 is? 3 to what power equals 81? Pretty much it's the same thing. 4 equals 2x plus 1. Have the same equation now. So it just depends on how I like to write it. Do I like to write it this way, or do I like to think about it this way? It just depends on how you guys like to think about it, on which way is going to work for you, because once I get to this point here, they're exactly the same, right? So x is going to equal 3 halves. So it's only that first step on that's going to be different on how you want to think about it. Do I want to change that 81 to an exponent, or do I want to just switch it to a log and then solve the log and go from there? Yeah, either way works for me. As long as you get the answer correct, doesn't matter. No. Okay? And sometimes trying to find out 3 to what power equals 81, that's a little hard sometimes. And then we already know if I put log base 3 of 81 into Desmos, it's going to give me 4. So that might be a quicker way to actually do it, is switch to the logarithms. Sorry. Switch to the logarithms. Okay? So on number 3, what they want us to do first, or what we need, not what do they want us to do. What we need to do is get the exponent by itself, the whatever's with the exponent by itself. So I need to get this term right here by itself. So I'm going to use adding, subtracting, multiplying, dividing, the inverse operations to get that by itself. So this is 3 times 2 to the x power. So to undo times, I'm going to divide by 3. Then I have 2 to the x power equals 8. And this one you could probably just think about 2 to what power equals 8, right? But I can either rewrite it as a log and say log base 2 of 8 equals what? Which I'm still asking myself the same question, 2 to what power equals 8. Or I can try and rewrite 8 as base 2, which would be 2 to the x power equals 2 to the times 3 to the third power. So x equals 3 in either case. I don't care which way you think about it, either this way or this way. You don't have to think about it both ways, by the way. Just choose one, whichever one you like the best. But know that you may have to do both eventually. Okay? Questions? You guys are doing great. Okay, so shall we try? We have 6 problems here. Do you guys want to just try them for, let's have you guys try it and see how you do. And if you can only answer 4 of the 6, great. Okay, make sure you're asking me questions. We'll go over them in 10 minutes. Is that enough time for you guys to do the 6 problems? That's just a little over a minute a problem. These ones are a little easier, so I don't want to do too much time because I don't want to run out of time in class. So the first one, I'm gonna leave it this size. The first one just has the same base, base e. So if the bases are the same, I can just set the exponents equal to each other. So x equals -4, boom. The second one, again, the bases are the same. So I can, in order for them to be equal, the exponents have to equal each other. So x plus 8 equals 3x. Subtract x. 8 equals 2x. Divide by 2. X equals 4. Okay. On the next one, they don't have the same base, but this is kind of one that you can think through. But I'm going to redo it. So I'm going to rewrite it. I kind of like doing it as a logarithm because we kind of have to get used to it. So I'm going to rewrite this as log base 5 of 1/25 equals x. And so x is going to equal to -2. And I think if you put that into your calculator, make sure when you are putting it in your calculator, even Desmos, you're putting the parenthesis around 1 divided by 25. And you should get -2. Okay. And then we've got letter D. And again, my bases are the same. So I'm going to slide this up now. So I've got x plus 6 equals 4. Subtract 6. So x equals -2. Beautiful. And then for E, I have to try and get the exponent by itself. So I'm going to divide by 5. And so I get 2 to the x power equals 8. And we already solved this problem. So we should know that x equals 3. We solved it. If you don't remember when we solved it, I'm going to show you. We solved it right here on number 3, 2 to the x power equals 8, just in a different form. So they should have the same answer because it simplified down to 2 to the x power equals 8. So they should be the same. And then on F, I'm going to change both bases because if I change this to a logarithm, if I change this to log base 8 of 16 equals x and I put it into my calculator, I'm going to get a long decimal, right? It's probably going to be 1.333333333 repeated forever. So that doesn't give me a fraction or the number I need. So unless they tell me that I can round the answer, I need to give them the exact answer, which means I need a fraction, not a decimal. So I am going to think about changing the base of this. I know 8 I can write as 2 to the third power, okay? So, and 16 is just times another 2. 8 times 2 is 16. That means I can write this as 2 to the fourth power. So sometimes I'm just going to rewrite the whole thing in a different base, both of them in a different base, different but the same base. Oh, that doesn't make sense either. I'm just going to write them with a different base, but I want that base to be the same. There we go. That's better. Okay. So this would be 3x equals 4. Divide by 3, and x equals 4/3. Okay? Is there any questions on any of those? Good. Okay. All right, so now we're going to, so this was the exponent one, so we solved the exponents. And in Delta Math, you'll have both this type of problem and the next type. I'm pretty sure anyways. And what we're going to do next, which is the logarithms. So now we're going to do the second rule, which says if my bases are the same on the logarithms, okay, I'm going to set them equal to each other. So if I look at this, I've got log base 3 and log base 3. Those are the same. That means in order for them to be equal, which it says they are equal, so in order for them to be equal, this part has to equal this part. So x plus 2 has to equal 4. So subtract 2, x equals 2. Done. Is there any questions? You guys are doing good, by the way. Even though not everyone's answering, you're still doing good. Most of you guys are putting answers in. I haven't done A yet, Marco. Are you talking about this A over here, right underneath there? I haven't done that one yet, so I'm going to trust you. I'm going to do it in a minute. So on the second one, again, same base, they have the same base. So I'm just going to set them equal to each other. So 10 equals 1/2 times x. Well, how do I undo a fraction? Well, I multiply by the denominator. So that gets rid of that, and I get x equals 20. Okay, so is there any questions before I slide those up? Not too bad, you guys are okay? All right, so there are 6 problems. I'm going to make them smaller. So when I read on it, so my bases are the same on A. So my bases are the same, so that means I can say that 2x plus 3 is going to equal 3x plus 1. So subtract 2x, subtract 1, and I get 2 equals x. Beautiful. And then on the second one, I have 2x equals 6 divided by 2. X equals 3, just because my bases are the same. And remember, if it doesn't have a base, it's base 10, so both of them don't have a base, so they're both base 10. Let's go to C. This is 8 minus r. They both have the same base. 8 minus r equals negative 3r. So I'm going to add r to both sides. And I get 8 equals negative 2r. Divide by negative 2. R equals negative 4. So I'm going to pause just here just for a second. And I want to talk about this. Sometimes a negative answer does not work. Sometimes a positive answer. That one's more rare if a positive answer doesn't work. But because remember in here, in this portion here, I cannot have a negative number, right? So I can't say that log base 19 equals some, I don't know what it is. Let's just say some negative number, right? Some negative x. Because there's 19 to no power will equal a negative number, right? So that means that this number right here, this number right here, or this number right here cannot be negative when I substitute an answer in. But luckily, this case it's not, because I've got a negative 3 times a negative 4, which gives me a positive 12, which is fine. An 8 minus a minus 4, which is a positive 12 also. So that's okay. Tomorrow, I think all the negatives today work. Tomorrow, we have to be a little more careful with the negative numbers and seeing if they work or not. but I just want to put that thought into your head that we may need to think about start thinking about the negatives and making sure that they work with our logarithms, okay? So just something else for you guys to think about. So D, they have the same base. They're both natural logs. So I've got 72 minus 2x equals 10x. So add 2x, and I get 72 equals 12x. Divide by 12, and x equals 6. Yeah. Okay. And then we've got E and F. So natural log again, it's okay. They're both natural logs, so they both are equal to each other. So I can say that x plus 1 squared equals 4. Yes, we are. So how do I undo a square? Well, I square root it. If I square root one side, I have to square root the other. And that gives me x plus 1 equals 2 or negative 2. Two answers for square root. Subtract 1 from everything, and I get x equals 1 or negative 3. Please make sure you're asking questions if I do anything that is kind of like, what is she doing? Okay. And then for F, we've got, let's see, what do we've got? Same bases because they're log base 2. So I have x plus 5 is going to equal x squared minus 1. And I have a square again, so I'm going to bring everything to the same side of my equal sign. So I get 0 equals x squared minus x minus 6. So I can factor that. And sorry if you haven't seen the cross thing, it's how I factor and how I think about it. So I need two numbers that multiply to be negative 6 and add to be negative 1, which is negative 3 and 2. So this factors to x minus 3 times x plus 2. So I have two things multiplied together that equals 0, which means one of those things has to be 0. So either x minus 3 has to equal 0 or x plus 2 has to equal 0. So add 3, subtract 2. So x equals 3 or negative 2. Okay? That's it.